Everyone, this lesson recaps the live lesson that you had on Monday the 26th of April. It's going over how we simplify SURDS, multiply and divide SURDS, add and subtract SURDS, and a bit of a summary of all those topics together. So watching this lesson, pausing it, having a go at the questions will really consolidate your knowledge, and it will make you 100% prepared to go ahead and answer the homework that we've got for today. So today, at the end of this lesson, you must make sure you're on Haggerty and you've completed clips 116 and also 117. So get onto Haggerty after this video. 116, 117, we're looking for above 85%, otherwise have a go at it again. And if you're really stuck, remember there's Champions Hour on Thursday and Friday that you can come along and join and ask any questions you've got. Okay, let's get started. So first off, we need to be able to simplify SURDS. So this comes up in a non-calculated paper. To be able to simplify SURDS, it means we're taking out any square numbers from the SURD that we've been given. And across the top here, I've written out your square numbers. So you've got 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, and 10 squared 100. So these you really need to know off by heart. These are your square numbers. Okay, you need to be able to recall them at any given point. So if we're trying to simplify root 24, I need to find the largest square number factor. In order to do that, I'm going to write the factors. So I write 24 here, and I'm going to write my factors. I'm going to write them in pairs, and I'm going to do it really methodically. So I'm going to start with 1, and I'm going to say 1 and 24. Then I'm going to go 2, 2 and 12. Then 3, 3 and 8. Then 4, 4 and 6. 5 doesn't go, so I cross it out. 6 does, but because it's already in my list, I know that I can stop. And that tells me that I have got the full list of factors. There's nothing I've missed out. Right, now my job is to go down this list. So I'm looking at all these numbers here, and I'm looking for the largest square number. So I'm looking for the biggest square number, and I'm going to use this list up here to help me. So I'm looking for the biggest one of these numbers that I can see in this list. So hopefully in this case you can see that there's only one square number in this list, and that is the number 4. So the pair that I'm picking is 4 and 6. That then means I rewrite my SURD as a multiplication. So I rewrite root 24 equals root times root. Now this is really important. In these square roots is going to go the 4 and the 6. So in the square root goes that pair that I've picked. So this pair here that I've picked is 4 and 6. The number that comes first is very important. I must put the 4 here and the 6 here. Remember, the reason for that is at the front, we always put the square number, always, because it's that number that's going to drop out for us. So root 4 goes at the front, and then you can drop that first square root out. So if I actually square root 4, I get 2 times root 6, and then when I finish off the answer, it becomes 2 root 6. There's a times in there, you just don't need to write it. Okay, let's watch that again. So this time I've got root 27. So same method, I'm going to find the largest square number factor. So I'm going to find all the factors using my very methodical method. This method is really important in so many topics: factorizing, SURDS, highest common multiple, lowest common factor. The list goes on, so it's really important you're good at doing this method, and it's foolproof. You'll get every single factor. So let's start. 1 and 27. 2's not going to go because it's an odd number. 3 goes 9 times. 4 doesn't go. 5 doesn't go. 6, well, 6 goes into 4 24 times, so 6 isn't going to go. 7 doesn't go, 28. 8 doesn't go. And then your last number here is, let me move this up. Your last number here is 9. And I know that I'm going to stop because 9 already appears on my list. So I can write here stop, and you know that you've got all the factors. So then you draw your stake around them, and out of those 4 numbers, I need to find the biggest square number. So I'm looking at those 4, and the only square number in this list is the 9. So there it is. So my pair is going to be 3 and 9. And now I'm going to rewrite this as root 27 equals root times root, and the first number is really, really important because this is the simplifying part. This is the bit that's going to drop out. So it's really important that you're writing 9 here and 3 here. And remember, the reason for that, 9 is your square number. 9 is the square number, which means it's going to drop. So this becomes root 27. Oh, let me try that again. This one's going to become root 27 equals 3 times root 3. And then you can stick those together. We don't need to write the time, so it becomes 3 root 3. And that's our surd in simplified form. Okay, so see how confident you feel on this. At the very least, I'd like you to pause now and at least get me the list of factors for 72. You need a lot of space. 72's got a lot of factors, and I want you to try and circle the highest square number you can find in your list. So if that's all you do for now, I just want you to have a go at that, pause and do that question. Okay, so you should be back with me now with a list of factors for 72. So let's have a look at what those are. We've got 72 at the top. Now, like I said, this is a long list. We've got 1 and 72. 2 will go in 36 times. 3, I think, also goes in. So I've got 3's into 72. Well, 3's into 7 go twice because that's 6, carry the 1, and 3's into 12 go 4 times, so 3 and 24. Does 4 go into it? I think 4 might go in as well. So 4's into 7 go once, remainder 3, and 3's into 32 go 8. So that's 18. 5 is not going to go into it, but any number that's got 5 as a factor must have a 0 or a 5 at the end. So 5 is definitely not going in. 6, I think 6 goes in as well. 6 into 7 goes once, remainder 1. 6 into 12 goes twice, so 6 and 12. 7 doesn't go because obviously 70. 8 goes 9 times, and then 9 is already on my list, so I write stop. So then I draw my nice snake around all these guys. And I'm looking for the highest square number, the highest, the biggest square number. Now, this is the first time we've got a challenge here because there are multiple square numbers in this list. So you've got to make sure that you've picked the biggest of them. So you could pick 4. You could pick 36. You could pick 9. So there are 3 square numbers in that list, and you've got to pick the highest. So to get the right answer, you've got to pick the pair 2 and 36. So let's look at how that breaks down. Root 72 equals a square root times a square root. This is a fundamental step here. You must make sure the square number goes first. So 36 goes here and 2 goes here. Why? Because 36 is my square number, and that's going to be the thing that simplifies. That's going to be the thing that drops out. So this becomes root 72 equals 6 times root 2, and then we tidy it up by writing 6 root 2, and there's your final answer. Okay, now still completely confused, I've got one more example for you. If you're happy with that method and want to have a go at one on your own so you can check, pause now, watch it. Otherwise, just watch this one more through before you have a go at some questions yourself. So I've got the list of square numbers. I've got 32. First thing I'm going to do is write the factors of 32. Methodical method. 1 and 32. 2 is going to go 16 times. 3 doesn't go because of 30. 4 does go 8 times. 5 doesn't go. 6 isn't going to go because 36 is in the 6 times table. 7 doesn't go because 35 is in the 7 times table. And 8, I know I need to stop because 8's already in my list, so I write here stop. So I draw my snake, and my snake goes like this. And I'm looking for the biggest square number in my list. So again, you've got the choice of a few numbers here. You could pick 4 and you could pick 16. You've got to pick the biggest square number that appears in this list. So hopefully that means we recognize you're going to pick 2 and 16. So we rewrite root 32 as the square root of 16 times the square root of 2. Why does the 16 come first? Because 16 is the square number, so it's going to be the thing that drops out. So this becomes 4 times root 2. And if I tidy that up, 4 root 2. Okay, and it's simplified. And this is a really important method that we're going to have to use within another question. So let's begin having a look at how you're going to do that. First, there's one more question. Let's do one more question to make sure we really got this solid. So root 48, let's write the factors of 48. 1 and 48, 2 and 24, Let's see if 3 goes. Well, 3 into 48. 3s into 4 go once, carry the 1. 3s into 18 go 6. So I've got 16. 4 into 48, so 4s into 48 go once and twice, so that's 12. 5 doesn't go. 6 into 48 goes 8 times. 7 doesn't go. And then 8, I can stop because it's already in my list. So now I draw my snake around and I'm looking for the highest square number, the biggest square number that's in that list. So square numbers I could pick the 4 or I could pick the 16. So you want to pick the 16 because it's the biggest square number, so 3 and 16. So root 48 becomes root times root. The first number's got to be the 16, the second number's got to be the 3, and that first number's always going to drop out, so it becomes 4 times root 3, 4 root 3. Okay, so now some time for you to have practice on this. I've got a set of questions here. Pause the video and I want you to have a go. I mean, you need to be doing at least 10 of these questions to make sure it's really solid in your head. So pause now and then we'll check the answers. Okay, great. So let's check your answers here. So you've got some answers on the screen as well as how it's been broken down. And you can see that the way it's been broken down is every single time there's the square number, there's the other number. So that's why it became 2 root 3, okay? Square number, other number. That's why it became 2 root 6. So check your answers. Again, pause if you want to have a look at some more detail and email me if there are any of these that you're not quite understanding. Right. Let's see how we're going to, and to finish off. So this is a nice task just to begin to recognise how far you've come. So I want you to have a look, pause your screen and try and create the pairs. So on here are the original SURDS and the simplified versions. So you've got to find how they connect. So for example, you might start with, let's start with root 18. So let's do this one up here. So root 18, well, the factors of 18 are 1, 18, 2 and 9, 3 and 6, 4 doesn't go, 5 doesn't go, 6 is on my list already. So here's my snake. And the biggest square number on that list is the 9. So I would circle the 9. So it's this pair that I want. So I'd write, okay, root 18 is the same as root 9 times root 2, which should give me 3 root 2. So I know that I've got to connect this guy with this guy here. So see if you can find the rest of the pairs for that question. Pause now. Okay, and if we wanted to check our answers, we could check them. So root 50 should have been 5 root 2. So this guy goes here. Root 45 should have been 3 root 5. This guy goes here. Root 32 should be 4 root 2. This guy goes here. And that leaves us with root 54, 3 root 6. Okay, next, multiplying SURDS. Now, multiplying SURDS is actually very, very straightforward. SURDS can multiply SURDS. Okay, numbers can multiply numbers, but a number and a SURD can't be multiplied. And that's what we've seen when we've been doing our simplifying. So when you write, for example, 2 root 3, that is the same as saying 2 times root 3. You just can't do anything with that because one of these things, this guy here, is a number or a whole number, and this guy here is a SURD. They can't be combined, okay? But if you look at this first example, root 3 times root 2 can be combined because they are both SURDS. So because they're both SURDS, you can combine them and this will become root 6, and you're done. Here, next example, you've got 2 root 2 times root 8. So it's easier here to do a bit like we were doing indices and think to ourselves, well, technically there is a number in front of that root 8. Technically there's the number 1. So when you've got a root on its own, it's a bit like having the number 1 in front of it, which means that I've got number times number, which is 2 times 1. And then I've got SURD times SURD, which is root 16. And actually, this is one of those special cases where root 16 isn't a SURD, it drops out. So root 16 is 4. So your final answer here is this guy times this guy. So final answer here is 2 times 4, 8. Okay, let's do one more. So here you've got 5 root 5 times 3 root 6. Well, let's do number times number. So 5 times 3 gives you the 15. And then you've got root 5 times root 6, which gives you root 30. So final answer here is 15 root 30. Okay. Now, time for you to have a go at some questions. So you've got 3 questions here. 1, 2, 3. Using the examples I've given you, can you just pause this video and have a go at these yourself? Okay, welcome back. Let's have a look at these answers. So first one, root 7 times root 3. They're both surds. There's no numbers at the front, so we can just go straight into saying, well, that's root 21. And you're done. Question number 2. You put a 1 in front of here and say, right, the number times the number is 2 times 1, which is 2. And the surd times the surd is root 6 times root 5, which is root 30. So the answer here should be 2 root 30. Final question. Here you've got 8 times 10, which is 80. And then the surd times the surd is root 6 times root 2, which is root 12. So we might take from that the answer is 80 root 12. But, unlike the other ones we've been looking at, root 12 can be simplified. You can simplify this by taking out a square factor. So if I wrote the factors of 12, let's see if I can move this up. So we've got a bit more space. Yeah, if I write the factors of 12, I would have 12 is 1 and 12, 2 and 6, 2 and 6, 3 and 4. And there is the square number in this. So there is a pair that would mean I could simplify this answer. So this becomes 80 root 12 is equal to 80 root. The square number goes at the front, so the 4 would go here, and the 3 would go at the back. This then, the 4 then drops out, so it becomes 80 times 2 root 3. So final answer here is 160 root 3. And that's it, fully simplified. And let's just show you why root 30 can't be simplified. So in that previous question, you couldn't simplify it. Well, if I did the factors of 30, I have 1 and 30, 2 and 15, 3 and 10, 4 doesn't go, and 5 goes 6 times. So when I get to 6, I know I have to stop because 6 has already appeared. When I look at those pairs, there are no square numbers. There are no square numbers. So that root 30 cannot be simplified. So the best thing is always just to double check, is there a square number that can go into this number? Write out the factors. If there's not, you know you've got a final answer. If there is, you're going to have to do a bit more working out to find that. Okay, so let's do some practice of these. Let me find you some. If you want to practice one where you're going to have to simplify as well, have a go at these. So number 1, let's have 3 root 5 times 2 root 10. Number 2, 6 root 3 times 4 root 15. Okay, so those two are straightforward surds multiplication, but when you get your final answer, you then have to also simplify the surd. So have a go at those two. Pause your screens now. Right, welcome back. Let's have a look at those 2 questions then. So if I just scoot this page up, we'll just look at the follow-up. So for question number 1, we should have number times number, so 3 times 2 is 6, and then root 5 times root 10, which is root 50. So first round, your answer is 6 root 50. But if I write the factors of 50, I get 1 and 50, 2 and 25, 3 doesn't go, 4 doesn't go, and 5 and 5. And then you've got a repeat, so that's when you stop. So when I draw my snake, there is a square number on that list. The square number you need to pick is the 2 and the 25 because 25 is a square number. So this becomes 6 root 25 root 2. Remember, the square number goes at the front, and the square number is going to drop out to become 6 times 5 root 2. So final answer here is 30 root 2. Okay, not 6 root 50. Let's look at that second question. So the second question here, you've got number times number, so 6 times 4 is 24. Surd times surd, root 3 times root 15. So 3 times 15 makes it root 45. So first round, the answer is 24 root 45. But you now have to check whether you can simplify 45. So 45 is 1 and 45. 2 doesn't go because it's an odd number. 3 goes, so let's look at 3 into 45. 3's into 4 go once, carry the 1. 3's into 15 go 5 times, so we've got the 15 here. 4 doesn't go. 5 goes 9 times. Let's just move this up. There we go. Does 6 go? No. 7 doesn't go. 8 doesn't go. And 9 is already on your list, so 9 is telling you to stop. So you draw a snake around them, and hopefully you can begin to spot now much quicker that you've got a square number on there, and it's this pair here because 9 is a square number. So this gets split up as 24 root. Think about what number comes first. Has to be the 9 because 9 is a square number, and the 5 goes here. So this becomes 24 times 3 root 5. Okay, and then you've got to do 24 times 3. So 4 times 3 is 12, carry the 1. 3 times 2 is 6, add the 1, 72. So final answer, 72 root 5. Okay, so that's multiplying surds. Now, dividing surds works in exactly the same way. Okay, you can do surds divided by surds, you can do numbers divided by numbers, but you can't do a number and a surd divided by each other. So if we have a look at this first example here, you've got root 90 divided by 10. So here, all I'm going to do is 90 divided by 10. So 90 divided by 10 gives me root 9. But actually, root 9 isn't a surd. I can square root 9. So final answer here, 3. Next one. Be root 72 divided by root 2. So I can do this because I've got a square root divided by a square root. So I'm going to do 2's into 72. Well, 2 into 7 go 3 times, carry the 1. And 2's into 12, 6. So the answer to this question becomes root 36. And again, you've got that unique situation where that is a square number. So the answer is 6. Okay, so pause your videos now and finish off these questions. Question number 1 for me. And remember, when you get to your final answer, 1, check that that surd can't be dropped out to a whole number. And 2, if it can't be, check that there isn't a square number that you can use to simplify it. Okay, so pause your videos now. Right, welcome back. So let's finish off these answers. So part C, you've got 200 divided by 8. So 200 divided by 8 should have given you root 25, which does just drop out to give you 5. Part D, 243 divided by 3. This gave you root 81, which dropped out straight to become 9. E, 294 divided by 6 became root 49, which would just drop out to become 7. F, root 80 divided by root 10 became root 8. Now that doesn't drop out, but it can be simplified because it can be split up to become root 4 root 2. So final answer here should have been 2 root 2. Okay, and same thing here, you've got root 120 divided by root 10. So that became root 12, but that will simplify. And I'll just simplify it up here so you can see it in full. Root 12 becomes root 4 root 3. So it becomes 2 root 3 as a final answer. 2 root 3. And 180 divided by 3 is root 60. But you're not done there. You've got to simplify 60. So let's do 60 as a full question. 60, the factors of 60 are 1 in 60, 2 in 30, 3 goes in 20 times. 4, let's look at how many times 4 goes into 60. Well, 4 into 6 goes 1, remainder 2. 4's into 20, 5, so 15. 5 goes into 60. Let's have a look how many times 5 go into 60. That's once, remainder 1. So 5 into 10 become 2, 5 and 12. Let me continue my list up here. 6 into 60 goes 10. 7 doesn't go. 8 doesn't go. 9 doesn't go. But 10 is already in my list. So 10 is telling me to stop. So my snake technically goes like this, all the way up and up here. And I'm looking for my highest square number, my biggest square number. So hopefully we can see that on here that's 4 and 15. So to finish this question off, you're going to be writing this as root 4, root 15. So 2 root 15 is your final answer. Okay, so dividing surds, same as multiplying, you can do surds divided by surds. Make sure you're simplifying your answers. Question number 2 is just to highlight a bit of a sneaky rule about dividing surds, which hopefully we went through in our lesson. So this sneaky rule, I move myself out of the way, this sneaky rule basically means that you can do the division first, but if it's easier to square root first, you can also do that. So in this case, in question number 2, I could do 1 divided by 9 and then square root it. But actually, because both these numbers are square numbers, I can do it like this. I could say, right, the square root of 1 over the square root of 9, and I can split it up like that. And that works very well when the numbers that you're working with are square, because the square root of 1 is 1, and the square root of 9 is 3. So your answer becomes 1 over 3. Look at B as another example. Because 4 and 25 are special, they are already square numbers, it's much easier for me to square root 4 and then square root 25. So square root at the top and then square root at the bottom, giving me the answer 2 over the square root of 25, which is 5. Okay, so that's just a bit of practice on those. So pause your video, have a go at doing C, D, E, F, and then I will help you on I and J, just a special finishing those off. Okay, welcome back. Let's just double check that we're happy with C, D, E, and F. So for C, again, you've already got square numbers there. So this becomes root 81 over root 36. So it should become 9 over 6. And if you want to simplify that further, you should be able to take a factor of 3 out. So if I divide the top and bottom by 3, I get 3 over 2 as a final answer. For D, you've got a square number on the top and a square number on the bottom, so it makes sense again just to square at the top and square at the bottom. We should have got 7 over 11. E is the same, so I've got the square root of 100 and the square root of 64. So that becomes 10 over 8, and again you can simplify that to 5 over 4 by taking out the factor of 2. Now F. F is similar to what we're seeing in I and J. You haven't got square numbers on here, but you can simplify your square roots to make the problem much, much easier. So instead of doing the division, and especially if this comes up in a non-calculator paper, instead of doing 18 divided by 200, what I'm going to do is I'm going to simplify both those surds and see what that leaves me with. So I'm going to take number 1, I'm going to simplify root 18. Now root 18, if I write the factors of 18, they are 1 and 18, 2 and 9, 3 and 6, 4 doesn't go, 5 doesn't go, and 6 is on my list. So I stop. So my snake looks like this, and I pick 9. So root 18 gets rewritten as root 9 times root 2, so it becomes 3 root 2. If I do a similar thing for 200, well, root 200, you might be able to spot some of these square numbers coming out straight away now, and root 200 is a common one for that. So instead of writing the factors, because I know that 100 is a factor of 200, I'm going to put that straight in because that's the biggest as it normally goes. So I'm going to turn that into root 200 times root 2. So that becomes 10 root 2. So look what happens here now. This fraction gets rewritten like this. I'm going to give myself a bit of space. This fraction gets rewritten like this. On the top, I have 3 root 2. And on the bottom, I have 10 root 2. Well, because I've got a root 2 on the top and a root 2 on the bottom, they actually cancel each other out to become 1. Any number divided by itself is 1. So this leaves me with, without really doing any division, 3 over 10. And I'm done. So again, if you're sitting on a non-calculator paper and you're thinking, how are they expecting me to do this question without a calculator? It's probably because they're expecting you to do this question without a calculator, so you need to find another way of doing it. So have a go at I and J. When we look at those numbers, 27 and 64, we might think to ourselves, okay, I could square root 64, but I can't square root 27. So can you think of a way of simplifying 27 so that you can square root it? And the same with J. So pause your video now. Have a go at these questions. Okay, welcome back. Let's have a go at these. I'm going to give myself a bit of space, so I'm going to just rub this part off. So, with I, if I think about the square root of 27, well, when I simplify 27, the factors of 27 are 1 in 27, 2 doesn't go, 3 goes 9 times, 4 doesn't go, I'm going to go over here, 5 doesn't go, 6 doesn't go, 7 doesn't go, and 8 doesn't go. So none of these guys go, and 9 is already on my list. So there's my pair. So it gets broken down as root 9 times root 3. So hopefully we can see that's 3 root 3. Okay. Now I can square root the bottom. So when I rewrite this, I rewrite it as the square root of 27 over the square root of 64. So on the top I get 3 root 3, and on the bottom I just get the 8. So that's my answer, 3 root 3 over 8. And you can do a similar thing with that last question. So you can square root 98. And when you simplify square root 98, you get 7 root 2. And if I square it 1, 2, 1, I get 11. So that's why my final answer is 7 root 2 over 11. Okay. Finally, adding and subtracting surds. So adding and subtracting surds, really, really important part of this topic. And it links directly back to algebra, and remembering that you've got to have the same family to be able to combine them. So if I link it back to algebra like we did in the lesson, 3x plus 4x gives me 7x's. 2x plus 3y cannot be combined because you've got different families there, so that just stays as 2x plus 3y. And the same is true for surds. So you can only combine surds when it is the same surd. You've got the family of root 2s, the family of root 10s. So if I look at these examples that are below, the first one, you've got 2 root 2 plus 3 root 2. So they are the same family. So the family of root 2s. So I've got 2 root 2s over here and 3 root 2s over here. So actually, in total, I have 5 root 2s, and I can only bring those two together. I can only do that combination because I've got both of them in terms of root 2. And you can see that much clearer when I do my second example, because initially when I look at my second example, there's nothing I can do because I've got the family of root 2s here and the family of root 8s here. So it looks to me like there's nothing I can do to combine them, but you do have to always check that neither of the numbers can be simplified. Now, root 2 can't be simplified, but root 8 can. The factors of 8 are 1 and 8 and 2 and 4. 3 doesn't go, and 4 is already on your list. So they're the only factors, and there is a square factor there. So I'm going to rewrite root 8 as equaling root 4 root 2, which gives me 2 root 2. So this actually becomes 4 root 2 plus 2 root 2. And suddenly now, you've got the same family going on. So now they can actually be combined. And your final answer here should be, well, I've got 4 root 2s over here and 2 root 2s here. So just like I would have 4x plus 2x, I end up with 6 root 2. Okay. Final example, and this is as hard as it's going to get. You're going to need to simplify both of these to be able to combine them. So you've got root 32 and 2 root 8. They can't be combined at the moment because you've got different families. You've got the family of root 32s and the family of root 8s. But you're just going to make sure that you can't simplify them down to become the same families. So let's start with 32. 32, facts of 32 go 1 and 32, 2 and 16, 3 doesn't go, 4 goes 8 times, 5 doesn't go, 6 doesn't go, 7 doesn't go, 8's already on my list. So my pairs look like this. Be careful, you might think you picked the 4, but actually it's the 16 and 2 that need to get picked. So root 32 becomes root 16, root 2, which becomes 4, root 2. Minus 2 lots of root 8. Now in the previous question I've already done root 8, so 2 lots of root 4, root 2. So 2 times 2, root 2, because that root 4's dropped out, so this guy's dropped out to become a 2. So I got 4 root 2 here, minus 4 root 2 here. Actually got the same thing. Got 4 root 2's minus 4 root 2. The answer here is 0. Okay, so when we are adding and subtracting, if you want to know your steps, number 1, have you got the same families? If you have, you can go ahead and add and subtract. If you don't, you need to go back to the method that we started at the very start of this lesson, which is to simplify your SURDS to check that you can't make them the same families. Let's see if we've got some questions for you to try on this. So here are some questions on the screen. Again, I want you to think about this exactly like I've shown you these questions, the example I've just done. In this first one, initially, we cannot combine these SURDS. So initially, I cannot combine this with this because they're different families. You've got the family of root 3 here and the family of root 12 here. But one of these SURDS can be simplified. This root 12 can be simplified. So when you're doing your working out, the way you're going to set it out is I want to see 12 here. You list the factors of 12 before I'm going to stop, and you pick your square number. So here it's the 3 and the 4 that's going to get picked. So this question becomes, so I'm going to rewrite the whole question out, 6 root 3 plus, and instead of writing root 12, I'm going to write root 4, root 3. Remember, the reason why the root 4 comes at the start is because it's 4 that is the square number, and the square number always comes first. So your next line would be 6 root 3 plus 2 root 3, because the square number drops out. Now, you're happy. Now you've got the same family. You've got the family of root 3's here, root 3's here, which means you can finish off the question and write that as 8 root 3. Okay? So for all of these questions, you need to simplify the SURDS first, like you did at the very start of this lesson, and then check that you've got the same families. And I'll give you a hint. Because we're practicing adding and subtracting SURDS, all these questions will break into the same families. So just make sure when you're doing this, you're breaking them down, you're getting the same families coming out. Okay, pause now, have a go at these questions. Welcome back. Okay, this is now checking our answers. Now, I've got to remind you, this is not easy maths we're doing here. We're talking grade 6, pushing on grade 7 work. So if you're understanding this and you're able to do these multiple methods, simplifying and then collecting them together, that is real expert maths that's going on. Here are the answers. So check your answers. Again, go back over it. Make sure you've understood where you've gone wrong. If you don't understand where you've gone wrong, that's absolutely fine, but that's the time to call me in. So drop me an email, come to Champions Hour, make sure that gets resolved so that you can move forward and answer the Hegarty clips for this week. Reminder, Hegarty clips 116, 117. That's it for today's lesson. Well done. You worked really hard. And again, I just reiterate, this is not easy math. This is multiple methods building on each other. So really well done for the dedication and commitment you're showing. You're doing a fantastic job. Keep going, and I will see you soon. Bye-bye.